this video to show the first draft of the pixel extraction code that a lot of you will maybe be interested in using and or adapting to your needs. So basically, in this example, I'm using the 500 or so pheno crowns, and I want to extract the pixel information. Let's assume I'm doing a classification by species, just using the 4 bands that are in this SkySat image. So zoom in here, you can see a bunch of these hand delineated crowns, which ideally are on top of trees whose pixel values I want to extract. Look in the attribute table. It's the critical elements here are that you need to have some column that is a unique ID for each of your polygons that will stay stable over time. So do not use FID as your unique ID. Make your own so that it stays the same and you kind of have control over it. The other critical column is some column that indicates the type or the class. In this case, the class is species, but it doesn't have to be. It could be like local climate zone type or anything else that you're trying, a land cover class or whatever. So the class here is not unique, but the UID has to be unique. Okay, so that's kind of the data, and I'm looking to do a classification of species in R. So what I would do next is go to the Alonzo Lab GitHub page and go into the Forest Analysis Utilities R. So you should all have access to that. And I've added this pixel extraction by crowns R code. So I'm not going to go through like the right way to get this code. I'm not going to show the GitHub way for now. We can worry about that later. For now, you can just click on it. Here's the code. You can just copy it, put it in RStudio. So this assumes that you've installed R and RStudio on your computer. Paste it in there, and you'll want to save it off as something for yourself. So basically, you can see the purpose of this code, the input files that you need, so your shapefile, path to your shapefile, and your image layers. And then the main goal is that you're going to output a data frame with all of your pixel values, and each pixel will be labeled by Polygon UID and class name. Then you can go further. If you want to output a CSV or something, you can do that too. So you need some R packages, and if you don't have them on your computer, you'll need to install them. But I already have them, so I'll activate them. Then here's the key kind of code that you need to interact with is the specify user inputs. So you need to have full path names unless everything is already in your working directory. So I've just gone ahead and specified full path names. So the name of the shapefile. So in this case, it's that DC pheno crowns, and I show the full path name. You need to specify which field is your UID, and this has to be an exact match. So just going back to ArcMap here, my UID is this UID field. So I specify that, and I specify the class field name, which is species code. I specify my image. This will come in as a raster stack, so it can be any number of spectral bands. So this image is a 4-band multispectral image. So let me run all this stuff, and I'm specifying my output file name or location also. You can subset your Polygon records if you want, but I would recommend probably just doing that before you just do that in ArcMap for now. It's probably easier. The rest of the code you should just be able to run without modifying, but it's still good to do it line by line just to make sure everything works. So it loaded everything in, and we're seeing I 53 here, and that said here's what it knows what the column names are in the shapefile. Shows some information about the shapefile. It's always good for reassurance that you're doing stuff right. Did I load the image yet? Maybe not. So I'll load the image. And if I wanted to, I could uncomment this and actually show the image. There it is. So it's showing a 432 false color image with a linear stretch. Now we're on to the extraction of pixel values. And so this just gives some information about what the parameters of this extract command are. So we learned about this from Janice the other week. And so I'm just extracting from my image using the polygons. I'm allowing to grab pixels in from small polygons that may be smaller than the pixel in question. It's going to create a data frame. It's going to provide weights, which is super helpful because it's going to show what percent of a pixel is inside the crown. So if only like 1% of a pixel is inside the crown, we'll be able to exclude that from analysis later. And I'm allowing the number of layers to just be the number of layers in the image from line 62. So in this case, the number of layers will be 4 because there's 4 bands. Now I'm just doing some stuff that needs to be done in order to align the output, which will be many, many pixels, with have each pixel also have a class code and a UID attached to it. So this is just some database manipulation stuff. So let me run all of this code. And this extract code can take a while. It's doing a lot of stuff. So I've got 569 polygons and a 4-band image. So it's going to take a little while. I'm working on parallel processing for this, but I'm not done with that now. So I'll pause and come back. Okay, after like 10 minutes or so, I'm back and this extract code has run, and now I'll do my joining of everything together. Well, looks like I already did that. So you can take a look here at this all crowns DF. The head means you just look at the first few lines, and so we've got just an ID that's not really important, but then you've got the actual pixel values. So in this case, it's the 1, 2, 3, 4 layers. It's got the weights, so only 1% of that pixel was inside, 77%. Many of them, when you go further down, are going to be 100%, so that's good. And then I've got my UID. And so this is what connects each pixel back to its parent polygon. So at this point, you've got a data frame that you can just start doing analysis. You can start doing classification on it because you've got the data and you've got the class field. You could also write to a CSV or something like that if you want to. So that's it for now. Let me know how we can make this code better.